Hey everyone, welcome to the YouTube channel of DCC NIT-A curriculum. Myself Mayur, a second year CSC undergrad at NIT-A curriculum. Today I am going to discuss the problem guess the permutation that came in Codeforces round 755 division 2. So before we start, the prerequisites are binary search and also you must know what is an interactive problem. If you don't know interactive problem, then I'll just give a brief idea about it. Like in your childhood days, you must have played some games with your friends where you used to ask your friend to think of certain number. Then you used to tell your friends to do some operations like you should tell that add something to it, add subtract something to it, divide something to it, divide something and multiply something to it, something like that. And after the end, you is to ask your friend that what is the current number, and based on that current number, you is to tell what was the original number that your friend thought of. So here, an interactive problem is also something like that, where you will be given some information initially, and after that, you will ask certain queries. The format for queries will be given in the question, and after each query, the computer will produce an output, and based on that output, you will process that, and finally, after asking multiple queries, you have to tell the correct result that the question asks for. Now, one thing to note here is that after asking each query, you have to flush the output. Now, what does that mean? I will show you in the code part. So now I will just come to the question. The question states that Jury initially had a sequence A of length n such that is equal to I. So let's say that the length is 5. So there will be a sequence of five numbers such that each of AI is equal to I. Let's say so the numbers can be of 1, 2, 3, 4, 5. Since each AI is equal to I, so the numbers will be 1, 2, 3, 4, 5. Now the jury chose three integers ijk such that ijk lies in the range 1 to n, and also j minus I is greater than 1. So let's say if we have chosen uh, is2, so you have to choose js4. You can't choose js3 because their difference should be at least greater than 1. So after that, jury reverse the subsegments I to j minus 1 and j to k of the sequence A. So what does that mean? Let's say if you take I as 1, then J, I will just do that with another color. Let's say you have taken I as 1, then J is 3 and K is 5. So first of all, you will reverse the subsegment I to J minus 1, that is this part. So after reversing it, the numbers will be 2 to 1 and the other subsegment is J to K. So this part, and after reversing, the numbers will be 5, 4, 3. So this is the whole thing after reversing 2, 1, 5, 4, 3. Now here the definition for reversing is given, and then you are given the number n initially, and you have to find out ijk after asking some questions. Here questions means queries. In one question, you can choose two integers l and r such that l and r also lies in 1 to n, and ask the number of inversions on the subsegment l to r of the sequence A. Here, what does inversion means? You will be given the number of pairs ij such that L less than equal to I less than J less than equal to R and AI greater than AJ. So I'll explain it with the help of the example. Let's say you have taken this part, this to this. Here you have taken LS1, sorry, LS2, L is equal to 2, that is this, and R is equal to this. So you will count that how many pairs are there such that the previous number is greater than the next number. So here you can see, is 1 greater than 5? No. Is 1 greater than 4? No. Is 1 greater than 3? No. Is 5 greater than 4? Yes. So I got 1. Is 5 greater than 3? Yes. So I got another one. Now is 4 greater than 3? Yes. So in total I got 3 such pairs such that AI is greater than AJ when I is less than J. So this is the definition for inversion. That is, you have to find out such pairs such that the previous number will be greater than the next number. Means not actually the next. It can be anything in the like following numbers. So the result for its query will be the number of inversions. Like when you ask a query stating calendar, so the computer will provide you with the number of inversions that will be the output for the query. Now find the chosen number ijk after at most 40 questions. So what does that mean? Is that you have to give the output IJK and you can ask at most 40 queries. You can't ask more than 40 queries. Now here it is also mentioned that IJK will be fixed before the start of your program and they do not depend on the queries. Now here let's take the input format. It will be, consist of multiple test cases, that is T. And for its test cases, the number will be single integer n will be given, where n lies between 4 to 10 to the power 9. And after reading it, we have to start the interaction process by asking queries. Also, we have to terminate our program if it is the last case, or else we'll proceed to the next test case. That is, if we get the answer, then we'll immediately terminate at that point. And the interaction process is something like if we have to ask a query with the uh, with L and R, so our query format will be question mark L and R. So you have to print this one question mark L R and then after printing it, you have to flash it. So then the computer will provide you with the value of x, that is the number of inversion. Here, note that if it is equal to -1, that means either you have asked an invalid question or you have exceeded the number of questions. That is, you have exceeded your queries more than 50, 40. So you have to terminate at that point only, or else there might be other issues. So that is it. Here, x is equal to the number of inversions on the subsegment L2R. Now, when we arrive at the answer, we'll print the answer as exclamation mark IJK. So this will be the format for printing the answer. And then here, see here that I said that you have to flash the output. So after printing this one, so we have to flash our output using this. Like for C++, we can use f flash stdout or cout dot flash. Here the same thing is given for other languages also. So you can just see that. So here you can see at the example here, like let's say if the original sequence was something like 21543, but it will be of course be not given to you. You'll be given only the number 5, that is n here, the number of integers in the array. So after that you will ask a query something like that question mark 1 to 5. That means how many what to say how many inversions are there between index 1 and 5. So here you can see 2 is greater than 1. So there is one inversion. 2 is not greater than 5. 2 is not greater than 4. 2 is not greater than 3. Then 1 is also not greater than anyone. Then 5 is greater than 4. 5 is greater than 3. So you get 2 more. And then 4 is greater than 3. So in total, you get 4 inversions. Also, see the computer has given you 4. So something like that, you will ask your queries. And after asking some queries, you have to print your answer, something like this. So that is the thing. Now, how to approach in this question? So for this, let's now take another example. Let's say I have taken an array of 1, then 2, 3, then 7, 6, 5, 4, then 10, 9, 8, 11, 12. Here you can see that this is one subsegment that is reversed, and this is the second subsegment that is reversed. So, like, how can you think of now? How can you approach this? Like, if you think in a bigger scale, let's say there is a huge array, there is a huge array, there is a huge. Now, let's say some of the part here, this one part is reversed, one subsegment, and this another subsegment is reversed. Now, how to find where, like, I have to find this part, right? I, J, and K. Now, how can you find it? If you think like I have to search for this. Now, how can I search? I can search something like I will first say for this portion, I'll first say like let's take a random portion. I'll first say, are there inversions here? If I see that there are inversions, that means the I will come before that part, right? If it has inversions, that means I will come here means anywhere between this. So I will again reduce my search space. I will again reduce my search space, and I will again search for smaller portion. Let's say this time I will search for smaller portion. Then again I will see that there are inversions now. So if I see that there are inversions, so I will understand that the reversed subsequence started somewhere from before already. So I will again reduce my searching space, and this time let's say I will search for a smaller portion. Now here for this portion, I will see that the number of inversion is 0. So I can simply say that this part has no inversions. That is, the subsegment starts something after this part. That is, I will be something after this part. So that will basically give you the idea for binary sets. Like you have to search for this. Like you will divide it into regions, and you will search for the region. If you see that there are inversions, then you take a smaller portion for it. That is the half portion for it. You will reduce the search space by half, and again you will see whether there are inversions or not. Now, if any point you notice that the number of inversion is 0, that means you have come to an edge. Either I starts from this position only, I starts from this position only, or else I starts from something after that. So in this way, you can do a binary search. This will give you a rough idea that here binary search is needed. Also similar for the last word also K. I can search for a bigger portion initially. I will see that there are inversions. Then I will generally go to a smaller portion. And when I will see that there are no inversions, so I can simply ignore this part. This part will not have K. K will be something before this part. So that way, the idea for binary search comes here. Now, here there are also certain observations here that you have to notice for proceeding further. Let's say here say that in one subsegment, how many inversions are formed? Because the each query will result in the number of inversions, right? So you have to first think of how many inversions are actually formed so that I can calculate. If I get the number of inversions from the query, so I will calculate it with certain formulas or something, right? So here you will first see that how many inversions are formed. Let's say here 7654 is one subsegment, so it is reversed. So how many inversions are formed? For 7, the inversions are 76, 75, 74. So 3 inversions. For 6, the inversions are 65, 64. So 2 inversions. For 5, the inversion is 1, 5, 4, and no inversions anymore. And for 10, 9, 8, the inversions are for 10, 10, 9, and 10, 8. So 2 inversions. And for 9, the inversions are 9, 8 only. So on. So you can see that it is going something like 1 plus 2 plus 3 plus 4, like sum of natural number. And actually it is going like, if the let's say the length of this subsegment is A and the length of this subsegment is B, then it is going up to A minus 1. That is 1 plus 2 plus 3 plus 4 plus up to A minus 1. Here A is 4, so 1 plus 2 plus 3. So total here 6 inversions are there, and here as B is equal to 3, 10 and it only the length is 3. So 1 plus 2, that is total 3 inversions there. So I can calculate the number of inversions as 1 plus 2 plus 3 plus dot 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 plus A minus 1 by 2, of course. Sorry, not by 2. And then 1 plus 2 plus 3 plus dot 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 up to B minus 1. And if I use the formula for sum of first n natural numbers, then it will come to A into A minus 1 by 2 plus B into B minus 1 by 2. So this is an important observation that you should make. The total number of inversions in the whole array will be A into A minus 1 plus B into B minus 1 by 2. So I'll note that up here. Total inversion. So this is the total inversion that you should know. Now, the second thing is that, like, for the second thing, I will just take it down here. Okay. Now, for the second inversion, for the second observation. Now, if you notice something like, let's say, for this part, for this part only, how many inversions are there? There are total 3 inversions. Now, if you go up to one place before, that is up to 10 9 only. Now, how many inversions get reduced? All the inversions get reduced which are for 8, that is 10 8 and 9 8. These inversions get reduced because 8 is not anymore in this space. So in total, two inversions get reduced, and the resultant becomes, the new inversion becomes 1. I will just explain it with a better example. Let's say the reverse subsequence is something like 10 9 8 7 6. So in total, how many inversions are there originally? So for 10 9 8 7 6, that is 4. I'll just simply use the formula. Since there are now n is here, the length is 5. So the number of inversions will be 5 into 4 by 2, that is 10. So 10 inversions are there initially in this portion. Now, if I reduce the portion, like if I just do count the number of inversion for this part. Now, how many inversions get reduced? Like, what are the inversions that get subtracted from here? Oh, here actually those inversions get subtracted that are actually formed due to 6. Now, which inversions are formed due to 6? The inversions that are formed due to 6 are 10 6, 9 6, then 8 6, and 7 6, right? So, if you see, like, if if the length for this is, let's say, b, if the length for this is b, then actually b minus 1 inversions get reduced, because see here the length was 5, so 4 inversions got reduced. If I have to search for this space now, if I have to search for this space, so this is another observation. Like, suppose you don't know the length here. Now, if you don't know the length, and you just suppose you just have a query for, let's say, L to R. Let's say this is Q, and you did another query for L to R minus 1. Now let's say this is Q1. Now you can find the length is, what will be the length? Length is their difference. Here, see, originally it was 10. Now the next one is 10 minus 4. Here 4 was separate. So the next inversion was 6. So here Q was 10, Q1 was 6. And so the length was 10 minus 6, that is 4 plus 1. So the length of this part was Q minus Q1 plus 1. This is another observation that you should make here. If you make two queries, something like query of L to R, and it gives you Q, and query of L to R minus 1, then which gives you Q1, then the length for that part, for that inversion will be, here L of course denotes the starting. L should denote the starting of that inversion, right? So here the query will ultimately give you the length for the whole reversed subsequence. So we will use these two observations now. Now, how to use those two observations? So for that, I will again take this example. Now, from the second observation, what comes to mind? Like, if we can somehow find our this index, like if we can somehow find the value of k, that is the last part where the inversion stopped, where our inversion stopped actually. If we can somehow find this one, then what I can do, I will do a query for the previous part. Originally, I could do a query for this part, that will give me one value. Or this part is also equal to the total number of inversions in the whole, because the later part has no inversion. So I can just denote it by the original one as, that is here Q will be, I will just denote Q is equal to total inversion, and I will get it from, I will just make a query of from 1 to n, where n is the length, right? So this will be my first test. That will give me the total inversion. That will give me the total inversion. So after getting the total inversion, that now the total inversion for this is equivalent to total inversion up to the last where the inversion stopped. That is here 8. So these two will be equal. Now, if I could somehow find this location, I will do a query for the previous part because we had an observation that if we could find the uh, output for the previous one also, then we can calculate the length. Now, if let's say if I do a query for this part, and let's say I have already k known, I could find k by some process. So I'll do another query q1 that will be query of 1 to k minus 1 because I'll go to the previous position for up to this position only. Now, if I get this part, and now if I subtract these two, k minus 1 and add 1, that is use this formula for length, I will get this length, right? I will get this length. How? Because here k contains all the inversions for this part also, and for this part also, right? Here k contains all the inversions for this part also and for this part also, right? All the inversions. Now, if I do a query for k minus 1, now k minus 1 will also contain the inversion for this part again. This part will also be contained, right? And this part will be contained this time now because I am doing for k minus 1. So I can see here the inversions for 8 will not be counted. The inversions for 8 will not be counted. That was happening in our original case here. See, so from this, I'll get see that how many inversions are formed actually due to it, and from that I can calculate the length of B. I hope you got it. If I have to do a dry run for this, let's say if I find the total number of inversions here, how many inversions are there? For 7, it is 7 6 7 5 7 4, so 3. Then for 6 6 5 6 4 2. For 5, it is 5 4 only 1. And then for 10 10 9 10 8. So 2 for 9 1, right? So these are the total inversions for up to k or up to the whole length. Now if I do an inversion for the previous part, so what are the inversions that we get? So again for 7 7 6 7 5 7 4, that is 3. For 6 6 5 6 4, that is 2. For 5 5 4. Now for 10 10 will go till 9 only. 10 won't do anything with 8 because 8 is outside our range because we are doing only up to k minus 1. So here it will be 1 and then 9 have none. So here see, only those things got left out that are actually dealing with the last value, that is the kth value. So from this we can calculate the value of b, right? Because if we know that for 8 two subsequent 2 got left out, so I can say that the total length was 3 because 2 got left out means the previous ones from the subsequence got left out, and 8 also is also there. So in total, that length will be their difference plus 1. So I can calculate the length of bx. B is equal to q minus q1 plus 1. That's how I got the length for b, right? This is for the part b. Now, how can I get the value for a? Now, for finding the value of a, what will I do is, okay, so as we know, the value of the total number of inversions that is stored in Q, right? So now we also know the value of B. So we can calculate like how many inversions are actually formed due to this whole part. This whole part. We can calculate this, right? By B into B minus 1. So from this we can also calculate like for the A part, how many inversions are formed. So let's write it here. We know here Q is total. We also know B, that is the length of second subsequence. Yes. So now the B part will contain, that is the B part will contain how many inversions? That will be equal to B into B minus 1 by 2 by the previous formula. Now from this I can also calculate like how many inversions will the A part contain. Now A part will contain Q minus B part, right? Total number of inversions is Q. This is the inversion is the B part, and so if I subtract this, I will get the inversions in A part. So also I can write the number of inversions in A part as A into A minus 1 by 2. That is from the formula. So now I can let's say this value is, let's say, is equal to x. Let's say this value is equal to x. So from this I can form a quadratic equation. See here, I know that in A part the inversions will be A into A minus 1 by 2, and so the let's say the value is x. So if I do cross multiplication here and write this as a square minus a, it will be 2x, or a, a square minus a minus 2x is equal to 0. So now I can use the formula here. A is equal to minus b, that is it will be 1, plus minus b square, that is 1, minus of 4 minus 4ac, so here minus 2x, so it will be plus 8x by 2. So here you can easily notice that I can just remove the minus part here. I don't need a plus minus. I can just deal with the plus part, because the minus part will can lead to some negative values, and we know that length can be negative. So from this we can also get the value of a is I plus root over I plus 8x by 2. So that's how I got the value of a, right? So now I know the length for both. I know that the first subsequence has length A, that I can find from here. The second subsequence has length B, that I derived earlier. And also I know K, that is the this value. Now still I didn't discuss how did I find out K. I will just discuss it now. So if you know now A, B, so that's, let's say this is the whole array. You know that this part is A, this part is B, and it is K. So if you just subtract from, if you subtract from k, that is k minus a minus b, and add 1, you will get this index I, right? You'll get this index I. And similarly now if you just add, or if you just subtract from k minus b plus 1, so you will get the j here. Or else you can also do something like I plus a plus 1. That way also you can get the value of j. Sorry, here I note that I have taken IJK as zero based indexing, so I have added one extra. Here IJK are zero based index, so I have added one extra. So you can just think of that, and you will realize that this is not such difficult. So now our main task is, how did I find K? Now finding K is very easy using binary search, right? As discussed actually in the beginning, right? If I like, if there is a, this is the whole array of numbers. Now what I can do, and I know that the for the whole part the number of inversion is q. Now what I can do is, I will just first check for this part. Wait, I will just first check for this part, the first portion. Now if I see that, let's say this is q1. Now if I see that the number of inversion is actually less than q, that means there are also inversion is this portion also. That means k will be somewhere after this. That means after mid. Here, let's say this is L, this is R, and this is mid, right? Mid is equal to L plus R by 2. That is a normal binary set. So if I see that for the up to middle, the number of inversion is actually less than Q. So I can say that K is somewhere after that. So I will just increase, or means I will change the mid. I will change the mid to uh sorry, I will change the R value to not R, sorry. I will change the value of L to mid plus one. Mid plus one. So now our this is the normal binary search. So the new L will become here, will come here. The new L will come here. So now this is the mid. This is the mid. Now again, I will search for this portion. I will see that how many inversions are there from 0 to this part. How many inversions are there? So let's say this is again less than Q. Let's say this is Q2. Now this is again less than Q. So again, I will increase the search space. That is now the mid will come to here. The mid will come to here. Now this time I realize that the value means the number of inversion is has become equal to original. Let's say this is Q3 now. Wait, let me erase this. Let's say it was Q1 for this part, it was Q2, and now up to this, the whole thing it is Q3. Now let's say Q3 is equal to Q. So what does this mean? That means either K will lie here at mid or K will lie somewhere in between this part. So in this case, I will just change the value of R2 here. That means I will change R equal to mid. So now my mid will come somewhere in middle. Uh, the mid will come somewhere in middle. And again, I will see for this portion whether the value is less or not, like equal. If it is equal, I will again change the value of R to mid. And if it is more, then I will change the value of L to mid plus 1. So this is a normal binary search. So in this way, you can find out where K lies actually. Let's say K lies actually here. So you can find out where K lies actually. So after getting this K, what did we do? After getting this K, we had total number of inversion as Q. So now we got K. So we just had a query for K minus 1. K minus 1. If you take zero based indexing, so it will be from 0. So K minus 1. And from that, you could get the length, right? You could get B. That is the length for the second subsequence. If you get B, from that you get the how many inversions are there in B part. And now, if you get B part, after that, if you subtract it from the total number of inversions, you get the A part. That is how many inversions are there in A part. Now, we know that for A part, the number of inversion is A into A minus 1 by 2. So, we just use this value, oh, sorry, use this value, that is Q minus B part, and substitute it here in this equation. And from this equation, we just find the value of A from here. Now we know the value of A, we know the value of B, and also we know the value of K. Now we can easily find the value of index I and J. So I hope the solution is clear to you. Now I'll show the code here. Okay. So here I'll just come up from here. See here that initially I've taken the number of test cases, then I've taken n, and then first initially I queried for the whole array, that is from first to last. Here I have taken zero based indexing, so 0 to n minus 1. I have taken the query for the whole part. Now here I have declared a b, that is the length, and a part b part, that is the number of inversions in the a length and b length, and I and k, that is the I have not declared here j because j can be easily written in the form of I plus a plus 1, something like that. So I have declared those. Now here I have found here k using this function, that is solve 0 to n minus 1 and q. Now see here, as I have declared, as I have said earlier, I have done a simple binary search here. L and R are the values that is initially 0 to n minus 1, and I have done the binary search normally, that is mid is equal to L plus R by 2. Then I would just do a query from 0 to mid, and if I see that the number, that is the inversion, is smaller, then I just increase the search space mode. Sorry, not increase actually. I just move the L to the right, and if it is equal, so I just change the value of R to mid. It can never be greater because the maximum inversion is Q. So this is a simple binary search, and after that we got the value of K. That is the last index. So now I found out B using, see here, Q minus query of 0 to K minus 1. As I have said in the explanation part, here Q1 is query query of 0 to K minus 1. See here, I have written the same thing. Q minus Q1 plus 1. So this is the length of B. And B part contains how many inversions? B into B minus 1 by 2. And A part contains how many inversions? Q minus B part. There is a in number of inversions is in A. So the now the length is 1 plus square root of 1 plus 8A by 2. That is from the formula. That is the length of A was 1 plus root over 1 plus 8 A part. Here A part is the number of inversion by 2. So that's how I got the length A also. And now I here from there I got the index I is equal to K minus A minus B plus 1. And initial and at last I just outputted the value that is I plus 1, then the value of j that is I plus a plus 1, and the value of k that is k plus 1. Since I have taken zero based indexing, so I've added 1 everywhere. And now how did I do the query? Here, see, for the query part, initially there are two numbers L and R, that is for the values L R. Now if they are equal, let's say in some cases the value of L and R becomes equal, let's say 5 comma 5. So in that case we know that since it is it is about a single digit, let's say this is there and it is about a single digit only, so we can surely say that there are no inversions, so we can directly return 0 here. We don't need to ask for a query here. We can directly return 0 because we know that. Now, for other cases, we have here see printed question mark, then L plus 1. Since I have taken 0 based indexing and the query was in the form of 1 based indexing, so I made it 1 here, L plus 1 and then R plus 1. And I have used, see, I have flushed the output. And then I got the value of X, that is the number of inversions, and I have taken this as input. Now, here, as mentioned in the question, if it is minus 1, that means we have done some error, or we have already passed 40 cases, that's 40 queries. So I have exited from here, or else I have written the value of X here. So that was all for this problem. I hope you understood it. In case still there are any doubts, you can ask it in the comment section. I'll try to resolve it. Thank you.